Okay, so we have a car approaching an intersection, making a turn. It can either go left or right. The centripetal force is provided by the force of static friction. Why static and not kinetic? Remember that if it's kinetic, that means you are opposing sliding. And if you're able to make this turn, then the parts of your tire are coming in contact with the road and you're not sliding. What I mean by the parts of your tire, if these lines that are in the circle are just different points, individual points on your tire, and there's an infinite amount of these points if you want. So there's really super small. They are all coming in contact with that road as the tire turns in this direction. So there's no sliding going on because there's a point of contact that's happening very briefly without sliding. So that's why it's static friction. You can go ahead and put that into words. Explain what happens if mv squared over r is greater than this. All right, so where did this question even come from? Well, let's take a look at the free body diagram for each of these. You've got your weight going down, you've got normal force of the road going up, and then you have this static frictional force. Just a reminder, label your free body diagrams. All right, so frictional force. So if we're looking at the forces dealing with the circle, the centripetal forces, the forces going in minus the forces going out, or the stuff going in minus stuff going out, we have our frictional force, which is mu Fn equals mv squared over r, our centripetal acceleration. So if our centripetal acceleration is larger than this, then that means friction is not capable of providing the centripetal force to keep us in that circle. So what's going to happen? Well, we're going to not have friction. We're going to kind of blow off here and make a larger turn than what we're looking for. So these two have to equal each other. So as an engineer, you've got to figure out what is your safest speed to where you can go around this and create your speed limits for going around curves or whatever. All right, which turn left or right requires the car to slow down more in order to make the turn safely? Explain your answer. All right, so to make the turn safely, which one requires you to slow down more? Well, if we look at this relationship, mu Fn equals mv squared over r, which one do you have to have a smaller speed? Looking at speed, we know speed is squared, and we have r in the denominator. So if we have a smaller r down here, this is going to stay the same. All of this, the frictional force is going to stay the same. If we decrease the speed here, then what's going to happen up here? We need to decrease that as well. So with a smaller radius, we need to have a smaller speed to make this relationship still valid. If we have the larger radius in the bottom, then that means our speed is going to go up because remember, we're dividing by a bigger number.